Good evening. Today we are going to talk about chemical bonding, part 1. And there are two basic types of bonding that we'll be referring to. They are ionic bonding and covalent bonding. And we'll look at the definitions of those two on the next slide. This is just a little cartoon talking about how ionic bonds are formed. It's an attraction between a positive charge and a negative charge. But before we get to bonding, we need to talk about where the electrons are placed in the atom. We always fill at the lowest energy levels first. The lowest ones are the ones written here at the bottom, or we start at the first energy level. If we remember doing our Hogg-Hilton activity, that would be the first floor. Then we move up to the second, which has the S and the P's. The third has the S and the P's and the D's. Then the 4S, 4P, 4D, and so on. So that you always fill the lowest first. Each blank or each orbital can hold a total of 2 electrons. That's just another shorthand way of remembering that we fill the lowest energy levels first. There are two ways to write electron configuration. When we talk about the term electron configuration, all we mean is that it is how electrons are arranged in the atom. We can use the SPDF notation, which just looks at, it has a 1, it has the letter, and it has a superscript or an exponent. The 1 tells us the energy level. The letter tells us the orbital, S, P, D, or F, and the exponent tells us the number of electrons in each orbital. Or we can use the box notation, where instead of writing the exponent, we would write arrows to indicate you had 2 electrons in the first energy level, in the S orbital. Here's some more examples of diagrams: orbital notation, orbital diagram, and electron configuration, or that SPDF notation we talked about. We have 1 electron in the first 1s orbital of hydrogen, because hydrogen only has 1 electron. Lithium, on the other hand, has 3 electrons. So I start at the lowest level, the 1s. I put in 2 electrons there, because each orbital can hold a maximum of 2. When that level is full, I move up to the next level. That's a 2s, and I only had 1 electron to put in there. If you look, your exponents should total the total number of electrons in the atom. Boron has 5 electrons, so I put 2 in the 1s, 2 in the 2s, and then I go up to the next orbital, which would be the 2p, and put in 1 electron there. The electron configuration for that would be 1s2, 2s2, 2p, 1. Octet rule, very, very important rule for us to remember, and that is that all atoms lose or share electrons so that they get 8 valence electrons. Everything wants that magic number 8, except hydrogen, which only wants 2 electrons. Remember, valence electrons are the ones in the outermost energy shell, outermost shell of the atom. So oxygen here has 6 electrons, but it has 4 valence electrons. 4 electrons in its outermost energy level. I know valence electrons because they are the group number in the periodic table. So everything in that first column has 1 valence electron. Everything in the 4th column would have 4 valence electrons. Everything in the 8th column has 8, except helium, which only has 2. That's your exception to that octet rule. And then just here's another diagram of valence electrons and how we can write that, how we can make shorthand notations of that. Lithium, remember, has 3 valence electrons, so that's has 3 electrons all total. We would put 2 in the first energy level, that would be a 1s2. Then we would move up to the next energy level and put in 1 electron. So I have 1 valence electron, I have 1 dot in the outermost energy level. That means I put 1 dot beside the symbol Li. Nitrogen, on the other hand, is got a total of 7 electrons, so that's going to be 1s2, 2s2, 2p, 3. 2 plus 2 plus 3 is 7. I have, in the outermost energy level, I have a total of 5 electrons. 1, 2, 3, 4, 5. So I put 5 dots around my nitrogen. Octet rule says you want to get 8 dots around each element. Everything is going to move or react in order to gain 8 electrons. Okay? All right, that's it. We'll talk about more about definitions of ionic and covalent bonding in parts 2 and 3. Have a good night.